Okay, so what we're going to do now is we have two things on the agenda today, okay? So if we have to maybe extend the class a little, like 5, 10, 15 minutes, so please do bear with me, okay? Because my intention was to finish this topic in the last class, but we couldn't keep class on Thursday. So yeah, we have to make up for it. Combined mean, variance, and standard deviation.
Sir, you said you will make a video on how we can do it on calculators directly.
Yeah, I haven't done that yet. Yes. Okay. Thank you for reminding. I will do that, inshallah. Okay. Okay. So this we're gonna do combined mean and standard deviation. We're gonna do with the help of an example only. Okay. So let me write down the date. Today is the 11th of Feb, 2024. Okay. Now, this is actually a past paper question, although it's not very recent. It's quite an old one, but it's still very relevant. Okay. And you have questions like these in past papers these days as well. Okay, like I said, it's a very relevant question. So let's see what it says. It says a group of 10 married couples and 3 single men found that the mean age x bar of 10 women was 41.2 years and the standard deviation of the women's age was 15.1 years. Okay. For the 13 men, the mean age XM, okay, that's what they've called it to distinguish, was 46.3 years and the standard deviation was 12.7 years. Find the mean age of the whole group of 23 people. Okay, so if you want the mean age, what do you have to do? Here's what you have to do. I'm going to solve this question. I want you guys to pay close attention. So the first thing I'm going to do is I'm just going to write down the data that we have. So the mean age of the men, actually let's start with women, is 41.2 years. Okay. And the mean age for men is 46.3 years. Okay. If I want the combined mean, if I want the mean of the whole group of 23 people, how am I going to do that? Here's how I'm going to do that. So first, I will find out the sum of all the ages of the women. In it, I will add the sum of all the ages of the men. Okay. And what will I divide it by? I will divide it by the total frequency. Okay, and how will I find out the total frequency? We have 10 married couples and 3 single men. So what is that equal to? 10 married couples means what, by the way? That means 23. Okay, it's given in the question also. Okay, so the total frequency is 23. Now the question is, how do I find out? And this is, let me tell you, this is an O level IGCSE level question. How do I find out the sum of all the ages of the women? How do I find out the sum of all the ages of the women?
Multiply by the total number of women.
Exactly. So what do we have? We have the mean, right? So I have the mean age of women, 41.2. What is mean going to be equal to? The mean is going to be equal to sum of all the ages divided by the total number of women, which will give me what? Which will give me the mean age of the women. So what do we have? We have the mean, which is 41.2. We have the number of women that we're talking about, that's 10. So that will give me what? That will give me the sum of all their ages. So if I multiply, what do we get? We get 412. So that means this is what we have so far. Just like that, we will find out the sum of all the ages of the men. How? Here's how we're going to do it. So we know that the average age of all the men is 46.3. How do you calculate the average? The average is calculated by first finding the sum of all the ages divided by the total number of men, and that will give you the average age of the number of men that you have over here. How many men do we have here? We have 13 men. What's their average age? It's 46.3. Through this, can I find out the sum of all their ages? Yes, I can. So 46.3 multiplied by 13, that's 601.9. Okay, so what do we have? We have sum of all the ages of the men. Any questions so far? Because from this point onwards, we're just one step away from the final answer. But if you have any questions so far, feel free to ask. Okay, great. I'm judging by the silence, no questions. So now, here's what we're going to do. 412 plus 601.9 divide by the total frequency, which is 23. Let's see what we get. 412 plus 601.9 divided by the total frequency, which is 23. That gives us 44.082. And then in the end, when we're giving our final answer, we say 44.1 is the combined mean. Now, take a good look at this question. Let me know if you have any, or let me know if there's anything you don't understand. And then we'll move on to the next part. Combined mean is easy. Combined variance and standard deviation is somewhat technical compared to combined mean. No, we didn't add their mean. All right, we didn't add their mean. We added their total ages and then divided by the total frequency. Okay, if you take the average of the ages, okay, if you let's say you take the mean age of men and you take the mean age of women and then you take out their average, you're actually calculating the average of the averages. Okay, that's not what the question is asking. The question is asking to find the mean age of the whole group. That's what the question is asking. There's a difference. Okay, so any questions? Yes or no? What is 412? 412 is the sum of the ages of women. That's what 412 is. All right, now moving on. Next question. The next question is, next part. The next part is, the individual women's ages are denoted by XW and the individual men's ages are denoted by XM. By first finding summation x square, that means by first finding the square of the sum of the squares of the ages of the women and the sum of the squares of the ages of men, find the standard deviation for the whole group. Okay, so a question like this, I think is going to be around, I would say, 4 marks. Okay, 4 marks easily. All right. So let's see how we're going to approach this question. So first of all, remember that the question has given you the standard deviation. All right, the question has given you the standard deviation, and in between, I'll keep asking you guys if you have any questions. So please let me know then only. Okay, don't wait for me to get to the end and then tell me that you don't understand. Let me know there and then only. So we know that the standard deviation of, yes, this recording will be uploaded, inshallah, 30 minutes after the class. Okay, give or take. All right, so the standard deviation of the women's ages was 15.1 years. All right, so I'm doing part 2 now. There's a lot of calculation that's going to go on over here. The standard deviation of the ages of the women is equal to what? Is equal to 15.1 years. Okay, and the standard deviation of the ages of men is 12.7 years. Okay, so all I've done so far is just copy down the data. Now, what do we have to find? We first have to find the summation x square for women. What formula are we going to use? This is the formula that we're going to use. Standard deviation is equal to square root of summation x square divided by the total frequency, or n, okay, minus the mean squared. Okay, so minus the square of the mean. All right. So we're at the moment we're talking about women. Okay, at the moment we're talking about women. So what's the standard deviation? The standard deviation for women is 15.1. Okay, this is equal to square root of summation x square. I'll write w here so that we know that we're dealing with women. How many women do we have in this group? We have a total of 10 women. So divide by 10 minus the mean. What's the mean? The mean age of the women is 41.2 years. So minus 41.2 squared. Okay. Now this is the equation that I'm going to solve. And once I solve this equation, I get summation x square for women. Okay. Now how will I solve this equation? Question for you guys. This is an algebra question now, not a stats question anymore. How do I get rid of the square root? Take square on both sides. Okay, and then what happens to this 41.2? So this part I'm going to do it directly on my calculator. Okay, so 15.1 squared, there you go. In this, I'm going to add 41.2 squared. Okay, so this is what we're looking at. The reason why I'm doing everything on my calculator is because I don't want to write down a rounded off value. And then I multiply that by 10. So when I do that, here's what I'm looking at. I'm looking at 19,254.5. Okay. Any questions so far? Don't worry about what we're going to do next. Don't even tell me what we're going to do next. But let me know if you have any questions so far. Okay, great. Let's do the same thing for men. Okay, let's do the exact same thing for men. So again, we're going to use the exact same formula. The standard deviation is equals to summation x squared divided by the number of men minus their mean squared. Okay, so the standard deviation for men is 12.7. Okay, given in the question. Summation x squared for the men is what we have to find out, divided by the number of men, which is 13, again, given in the question. Okay. Next is subtracting the square of the mean, which is also given in the question, and that is 46.3. Yeah, that is 46.3, the whole thing squared. So I'll work this out again using a calculator. So 12.7 squared. In it, I'm going to add 46.3 squared multiplied by 13. So here we are. We have summation x squared of men, which is equal to 29,964.74. Okay, what are we going to do now? Question for you guys. If I want the combined standard deviation of the whole group, what am I going to do?
You will add both of them.
Add both of them, correct. Divide by what? What total number of people? Very good. And what mean am I going to subtract? Will I subtract the mean of men, the women? Yes, I will subtract the mean of the entire group, which we found out earlier to be 44.1. Okay, so let's do that. We're almost there. So here we are. To find out the standard deviation of the entire group, here's what we're going to do. 19,254.5 plus 29,964.74 divided by 10 plus 13. The reason why I'm writing it as 10 plus 13 is so that later on when you guys are revising, you know exactly what I've done. Minus 44.1 squared, okay, which is the combined mean. And yeah, don't forget to take the square root. So once you work this out, let's see what we get. Plus 29,964. Make sure that you use the fraction key. Minus 44.1 squared. So after we round it off, we get 14.0. 13.97. Once we write it correct to three significant figures, we get 14.0. Okay. So this also is a very important concept, and you have past paper questions pretty much exactly the same as recent past paper questions, pretty much exactly the same as the one that we have done here. In fact, I'm going to make you guys do a question right now, but let me know if you have any questions so far.
So what is the purpose of finding standard deviation?
Standard deviation, like I said, variance tells you how much your data varies in comparison to the mean. Standard deviation tells you how much the values vary when you compare them. Like for example, over here, we wrote down exactly. It helps us in identifying the consistency. So variance is the measurement of the spread between the numbers in a data set, helps us find out how consistent the values are, tells us how close the values are to the mean in a data set. Standard deviation basically tells us how close the values are to one another. So if the standard deviation is low, if you have a lot of data, if you have a lot of values and the standard deviation is low, that means all the values are close to one another. Okay, if you have variance and the variance is, let's say, 5. Okay, now what does that mean? 5 means that, on average, the difference of all the values compared to the data set is around about 5. That's the purpose. The whole purpose, remember, the whole purpose of finding out mean, median, mode, variance, standard deviation, all of that is so that we can make sense of the data set that we have and make decisions. Here it is. Read the question carefully. Use your calculator wisely. 44.8. Let me see if that's the correct answer. That is the correct answer. Good job, Rabia. Okay, now see if you can do part 2 correctly. Notice part 2 is a 4-mark question. Remember what I said earlier? That there's a lot of working. So 4 marks are justified. It's actually 8.37. Nope, it's actually 8.37 or 8.36. 8.37 or 8.36. 8.37, yeah, 8.37 is the correct answer. Maybe we should have taken more significant figures. Yes, definitely you guys should have taken more significant figures if it's not your final answer. If it's not your final answer, yes, you should have definitely taken more significant figures. So, can you tell me summation x square? Let's start from there. Tell me summation x square. See, that's the problem. Yeah, 29162.55. 29162.5. Since it's not your final answer, you're going to take the exact value. Okay? What do you get, Vese? Tero, let me check. 7.65 squared plus 48.7 squared into 12. Yeah, see, since it's 29162.55, you got to take the exact value only. Okay? And then tell me summation y square. Please don't throw away your marks like this, okay? You're going to regret it. Can you tell me summation y square?
1024.75.
That is correct. 10284.75. So if you're using these values, then you're definitely going to get either 8.36 or 8.37. Okay? So carrying on with these values, the combined variance, combined standard deviation, sorry, turns out to be 8.36 or 8.37. Okay? Now, any questions? If yes, feel free to ask. If not, let's move on quickly. Part 2. Okay, I'm not going to do all of part 2. Okay, I'm not going to do all of part 2. I will do it partially. So if you want the combined standard deviation, then you can find summation x square first, and here's how you're going to do it. Hanya, if you take the rounded off mean, or either even if you take not the rounded off mean, your answer will still fall inside the acceptable range. Okay, but more importantly, everything that all the calculations that you're doing in part 2 only, you're not going to round those off. Okay, if you're using a value from the previous part, you can use the rounded off value, but within the same part, you can't use the rounded off values. Okay, so in part 2, here's what you're going to do. Sir, can you please confirm the formula of combined standard deviation? Okay, I'll write down the formula of combined standard deviation. So in part 2, let's start with art class 1. Okay, so there are 2 art classes. Let's start with class 1, which has standard deviation 7.65. So that means 7.65 is equals to square root of summation x square divided by the number of people in this art class. So that's 12 minus the mean, which is 48.7 minus the square of their mean. So when you solve this, you get summation x square, okay, which is right here. This is what you end up with. Okay, and then let's talk about the other art class where the standard deviation is 4.2, and that's equal to square root of summation y square divided by the number of people in this art class, which is 7 minus the mean, which is 38.1 squared. And then when you solve this, sorry, this is actually summation y. The question has distinguished by calling one x and the other y. So if you solve this, you get summation y squared to be 10,284.75. And please do not use the rounded off value. This is an exact value, so use it as it is. Then you're going to find out the combined standard deviation. The formula for which, okay, I'll write down the formula as well. Okay, the formula for which is going to be square root of summation x square plus summation y square divided by the number of people in one group plus the number of people in the other group minus the combined mean square, okay, which you already worked out in the first part. Okay, Taha, this is what you're going to do. All you got to do is plug in the values, 29,162.55 and 10,284.75, divide by 12 plus 7, which is going to be 19, minus 44.8, whole thing squared. Okay, if you're familiar with the formula, let me tell you something. If you get familiar with the formula, then this becomes easy. But if you're not familiar with the formula and you get agitated by these long calculations, then I can guarantee that you're going to struggle. Okay, so you got to get yourself familiar with all the formulas, and only then you will find yourself being comfortable with these super long calculations. Okay? All right, now moving on. Now what we're starting is something that's called coded mean, assumed mean. There are multiple names for this concept. Okay, and it's also called linear transformation of data. Okay, so there are multiple names. Let's write them down. So it's either called combined, sorry, not combined. We just did combined. Coded slash assumed mean, variance, and standard deviation. Or it's also called linear transformation of data. In essence, what we're going to do in this question is that we're going to see what happens to the mean, variance, and standard deviation when we add something to all the values of x, when we subtract something from all the values of x, when we multiply something with all the values of x, or when we divide something, when we divide all the values of x by something. Okay, that's what we're going to see. We're going to see the impact on mean, variance, and standard deviation. So we're going to do this with the help of an example right here. So in one column, I'm going to write down all the values of x, just random values, okay? What we're doing is we're trying to identify a pattern over here, okay? I want you guys to keep that in mind. So here we have, let's say 3, 5, 7, 8, 2, and 4, okay? So these are just random values from a data set, okay? Now, quickly, can you guys tell me the mean over here? What will be the mean of this data set? What are we going to do? We're going to add all the values, divide by the number of values. How many values do we have? 1, 2, 3, 4, 5, and 6. So let's do that. Let's see what do we get. Wait a minute. 1, 2, 3, 3, 5, 8. Sorry, there's no 7. Sorry. 3, 5, 8, 2, 4. Just these 5 values, okay? Okay, now if I want to calculate the average of this data set, let's see what do we get. So 3 plus 5 plus 8 plus 2 plus 4. So that's 22 divided by the number of values. So that's 4.4. Okay, so that means the average of this data set is 4.4. Okay, and how did I get the average over here? Summation x divided by the number of values. That's how we got the average to be 4.4. Okay, again, nothing new, something that you guys are all familiar with already. So the average of this data set is 4.4. Okay. Now what we're going to do is we're going to add 2 to all these values. Okay. I'm going to add 2 to all these values of x and see what's the impact. Okay. I'm going to add 2 to all these values of x, and then we're going to calculate the mean and see what the impact is. So if I add 2 to 3, we get 5. Adding 2 gives us 7. Adding 2 to 8 gives us 10. This becomes 4. This becomes 6. Now let's calculate the mean. Okay, so let's see what do we get. 5 plus 7 plus 10 plus 4 plus 6. Divide by 5, so we get 6.4. Okay, so if I do summation of all these values, x plus 2, divided by the number of terms, what do we get? We get 6.4. That means the average of this data set is equal to what? Is equal to 6.4. Okay. Now what you guys have to do is you guys have to keep an eye out for a pattern. Okay. If you figured out the pattern already, that's great. But if you haven't, just keep an eye out for the pattern. Now what we're going to do is we're going to subtract 1 from all these values, from the original values. Okay. Not 1 from this data set, but from the original data set. So what do we get? We get 2. 3 minus 1 is 2. 5 minus 1 is 4. 8 minus 1 is 7. 2 minus 1 is 1. 4 minus 1 is 3. Okay. Let's see what the data set or what the mean now is. So we will first find out the sum of all these values and then divide it by the number of values. So what do we get? We get 3.4. Okay. Again, keep an eye out for a pattern. There's a very strong pattern over here. Just keep an eye out on it. Just keep an eye out for it. Okay. Now let's multiply all the values by 5. So what do we get? We get 15. We get 25, we get 40, we get 10, and 20. And quickly, if you find out the average over here, that means if you take the sum of all the values that have been multiplied by 5 and divide by the number of terms, you know what you get? You get 22. Okay. Now last, let's take all the values of x and divide them by 10. So what do we get? 3 divided by 10 is 0.3, 0.5, 0.8, 0.2, 0.4. Okay. And here again, if you calculate their mean, That means find out their sum, divide by the total values. What you get is 0.44. Okay, now tell me if you have identified a pattern. The effect on individual values have the same effect on mean. That is correct. So whatever is done to the individual values in the data set is also done to the mean. That is also correct. Yes, Fahama, would you like to share what you've identified? Okay, so this is the pattern. All right, now let's read what I've written here one by one. First of all, if something is added to all values of x, the same is added to the mean. So notice we added 2 to all values of x. The same was done to the mean. The new mean turned out to be 6.4. Okay. If something is subtracted from all values of x, the same is deducted from the mean. Okay. So we saw that with the help of an example, that if you subtract 1 from all values of x, the mean, which was previously 4.4, turned out to be 3.4. Okay. Then if something is multiplied to all values of x, the same is also done to the mean. The same is multiplied to the mean as well. That's what we saw earlier. Previously, the mean was 4.4. Now it's 22. So notice what happens when you multiply 4.4 by 5. You get the new mean. And then, last but not the least, if something is divided from all values of x, the same is done to the mean as well. Okay, so this is the pattern that we wanted to identify. We could have just written this as well, but it's a good idea to actually see things happen right in front of us. Okay, so any questions so far? Don't worry about the use of this. Don't worry about how we are going to tackle this. Don't worry about that. Let me know if you have any questions so far. Okay, so to summarize what I've written here in a formula, this is how you summarize it in a formula. So summation x upon n gives you what? Gives you the mean. So if you do summation x plus or minus a divided by n, what happens as a result? The same is either added or subtracted from the mean. Okay, so this is basically a summary of the first two statements. If something is added, the same is added to the mean. If something is subtracted from all values of x, the same is deducted from the mean. Okay, so this is a summary of statement number 1 and 2. A summary of statement number 3 and 4 would be this. If all the values are multiplied or divided by x, then we do the same to the mean. Okay, so you can think of it this way, that here we're multiplying by 5. Here, although we're dividing by 10, but we can also say that we're multiplying by 1 upon 10. Okay, so if you're multiplying by 5, the same is done to the mean. If you're dividing by 10 or multiplying by 1 upon 10, the same is done to the mean. Okay, so this is a summary of statement number 3 and 4. Now, once again, do not worry about what a question on this will look like. Okay, but let me know if you have any questions as far as the concept is concerned. Because next we're going to see what happens to the variance. We've seen what happens to the mean. Now we're going to see what happens to the variance. Okay, great. Now, variance is when things get interesting. What do you think will happen to the variance if I add something to all values of x? If I add a certain number to all values of x, what will happen? No change? All right. Let's see. Let's see if you're right or wrong. So let's start by calculating the variance. Okay, let's start by calculating the variance of the actual data set. As the value is moved, so is the mean. Yes, so gap is the same. That is correct. Good job. Okay, so now we're going to see what the impact is on the variance. Okay, so here we're going to see what the impact is on the variance. Again, I want you guys to keep an eye out for the pattern. Okay, so let's take the original data set where we take all the values of x. So if I want to calculate the variance of this data set, what are we going to do? We're going to do 3 squared plus 5 squared plus 8 squared plus 2 squared plus 4 squared divided by the total number of terms minus the square of the mean. Okay, I'll just write down the answer directly. Okay. So the answer is going to be 4.24. Okay. So the variance is 4.24. All right. Now let's calculate the variance of this data set. Okay. So let's calculate the variance of this data set, for which we're going to do 5 squared plus 7 squared plus 10 squared plus 4 squared plus 6 squared divided by 5. And from this, we're going to subtract the mean. But what mean are we going to subtract? We're going to subtract the mean of this data set only, which was 6.4. The mean of this data set was 4.4. Okay, so minus 6.4 squared. And you guys are very welcome to try this out and tell me what you get. Try this out. Let's see what we get. So let's do it right now, in fact. 5 squared plus 7 squared plus 10 squared plus 4 squared plus 6 squared divided by 5 minus 6.4 squared. So what do we get? We get exactly the same answer, 4.24. Okay. Now, when we subtract something, then also you will notice that we'll get the exact same answer. I'm not going to do the entire calculations, but since we have started, let's just write it down. When you subtract something, when you take the variance of this data set, 2 squared plus 4 squared plus 7 squared plus 1 squared plus 3 squared divided by 5, and from this you subtract the mean of this data, which is going to be 3.3, then also you will notice that you get the exact same answer. The variance is 4.24. Okay. So, what do we say? When something is added or subtracted from all values of x, what happens to the variance? The variance remains the same. Okay, so let's write down the first two statements, and then we'll see what happens when you multiply something or you divide something by the variance. Okay, here we go. If something is added to all values of x, it does not impact the variance. If something is deducted from all values of x, it does not impact the variance. So let me tell you, you don't have in fact, you don't have questions in past papers where all the values of x have been multiplied by something or have been divided by something, but it still falls under linear transformation. Okay, so we're still going to see what happens. All right, we're still going to see what happens to the data set. Okay, so what was the mean of this data set? It was 22. Okay, what was the mean of this data set? It was 0.44. All right, now let's take this data set 5x and let's calculate the variance. Okay, so 15 squared, let's write this again, 15 squared plus 20, and I want you guys to think what will happen. Plus 40 squared plus 10 squared plus 20 squared divided by 5 minus 22 squared. Variance increases, okay, but variance increases by how much? Let's work this out. Whoops. Let's work this out and see what happens. So what we get is actually 106. What do we get? We get 106. Okay. Now think about it. Earlier the variance was 4.24. Now it's increased to 106. But what exactly is the pattern? Okay, think about the pattern that we have over here. And not only that, I will also calculate the variance of this data set, x upon 10. Okay, and then see if you guys can come up with a pattern. So won't the mean of x minus 1 be 3.4? Oh yeah, actually it's 3.4. I don't know why I've written 6.4. It's 3.4. Sorry. Actually, that is correct. This is incorrect. This is 3.4. I don't know where the 3.3 came from. Thank you for pointing that out. Multiply by the number squared. That is correct. Okay. So multiplying all the values of x by 5 resulted in the variance being multiplied by the square of that. Okay. So we'll write this down. We'll write this down. Don't worry. But this is what's happened. Multiplying all the values by 5 has resulted in the old variance being multiplied by the square of 5, and that's how we got 106. Okay. Now, can you tell me, without actually calculating the variance, can you tell me what the new variance of this data set is going to be, where we're multiplying all the values by 1 upon 10? That is correct, Mahad. What we're going to do now is we're going to multiply, to get the new variance, we're going to multiply the old variance by 1 upon 10 squared. Okay, we're going to multiply the new variance by 1 upon 10 squared. Okay, so again, you guys are very welcome to try this out. You'll notice that's what you're going to get, what Mahad has said. 0.3 squared. I'll work this out over here, in fact. 0.3 squared plus 0.5 squared plus 0.8 squared plus 0.2 squared plus 0.4 squared divided by 5. And from this, if you subtract the square of 0.44, you will notice that the new variance that you get is actually 0.0424. Okay? So, statement 1 and 2. If something is added to all values of x or if something is deducted from all values of x, it does not impact the variance. Okay? Now comes statement number 3 and 4. So, what's statement number 3 and 4? Let's write that down. Here they are. If something is multiplied to all values of x, the square of that thing will be multiplied to the variance. If something is divided from all values of x, the square of that thing will be divided from the variance. Again, we could have just written all these statements and memorized them. But the whole point of doing this example was so that you guys can see what the pattern is in the background. Okay? Now, any questions so far? If yes, feel free to ask. Again, do not worry about what the question is going to look like. That we will find out in just a few minutes. But let me know if you have any questions so far. Okay, now our main focus is going to be on the first two statements. Okay, you will not come across data sets where you will notice something is multiplied or divided by all values of x. Mostly you will notice that either something is added or something is subtracted. Okay, so if something is added or if something is subtracted, the variance stays the same. Agreed? If something is added or subtracted, the variance remains the same. So what does that mean? That means the old variance equals to the new variance. Okay, old variance equals to the new variance. Okay, and when does this happen? When something is either added or subtracted. Okay, when something is added or subtracted, we notice that the old variance is equal to the new variance. Now, how do you calculate the old variance? The old variance means that you have original data set. Okay, you have x. New variance means that something has either been added or something has either been subtracted from the data set. So if you have the original data set, how do you calculate the variance? Here's how you do it. Summation x squared divided by summation f minus summation x upon summation f, the whole thing squared. Okay, something we know already. This is what? This is the old mean. And these are your old values. Old values, or you can say the original values. This is equal to what? This is equal to your new variance. Now, how will you calculate the new variance? You will now take the square of the values after something has been added or subtracted divided by the total frequency. And from this, you will subtract the new mean. Okay, and how will you calculate the new mean? You will take the sum of all the values after something has been added or subtracted divided by the total frequency, and then you're gonna square it. Okay, so this is basically your new mean, and this summation x plus minus a, the whole thing square, are basically your new values. This formula is very, very important. I can't emphasize on how important this formula is. Very, very important. Okay, and everything that we have just done so far was so that we can understand this formula. Yes, I can repeat. I can repeat it as many times as you guys want. That's not a problem. But I want to make sure that you guys understand this right now only. Okay, and you will be, whatever is left, like if you don't feel like you're at your 100%, we will further understand this when we do an example. Okay, so what I want you guys to focus on is what happened to the data set when we added something or when we deducted something. What happened to the variance in particular? Nothing happened. The variance remained the same. What does that mean? That means the old variance equals to the new variance. How do you calculate the old variance? How did we calculate the old variance? We took the square of all the values of x divided by the number of values, and from that subtracted the mean of that data set. Okay, so that's what we did. We took the square of all the values divided by the total frequency, and from that we subtracted the mean, which we can find by taking the sum of all the values dividing by the total frequency. That's what we got. That's how we got the old variance. Okay, this is equal to the new variance. All right, so let's take this data set for example. What did I do over here? I took the square of all the values after 2 has been added. Okay, so I took the square of all the values after something has been added. This plus minus means that it could be plus or it could be minus. Okay, it's not like you're going to do both. This means it could be plus or it could be minus. And then I divided by the total frequency, which is 5. And from this, I subtracted the mean. Okay, what mean? The mean of the new data set, okay, which we can find by taking the sum of all the values after something has been added, dividing by the total frequency, and then squaring it. Okay, so this is how this works. Now, what is the use of it? That is something you're about to find out. But yeah, if you have any questions, go ahead. So straight away, we're going to do a past paper question. Okay, so here's an example. And this is a past paper question. Now, just by looking at this formula and just by doing one example, I don't expect you guys to be able to solve this question without my help. So I will solve this question for you guys, and then you guys can do a couple of questions for me. I'll solve this question. In fact, I'll do a couple of more questions as well. Okay. So let's first understand what we're given. Okay, let's first understand what we're given. It says, okay, this is a complicated name to pronounce, but let's just call it T. So T measured the arm lengths, X centimeter of 20 people in his class. He found that summation X, what does that mean? That means sum of the lengths of 20 arms, and the standard deviation of X was 4.2. Okay. Calculate summation X minus 45 and summation X minus 45, the whole thing squared. Okay. Now, First of all, let's write down the data set. Okay, let's write down what we're given. So what's the total frequency, or N? That's 20 because we're talking about 20 people. All right. What is the sum of all the values of X? It's 1218. Okay. And what are we given? We're given the standard deviation. If we're given the standard deviation, is there a way to find out the variance? How do I find out the variance? What do we do to the standard deviation? Square it, exactly. 17.64. Okay. Now, first of all, let's understand this. Summation X minus 45. What does this mean? पहले तो मुझे ये बताओ. First, explain to me, what does summation X minus 45 mean? Question for you guys. What does summation X minus 45 mean? Sum of all values of X with 45 subtracted. Okay. Now, yes, 45 has been subtracted from original values. How many values do we have? How many values do we have? 20. So if you're subtracting 45 from these 20 values, what does that mean? What is the total that must have been deducted? So we're subtracting 45 and we're subtracting 45 from 20 values. What does that mean? 900. That is correct. Good job. So, dekho, I'll write this down. Summation X minus 45 basically means that you took the sum of all the values of X and you subtracted 45. Not from 1, not from 2, but you subtracted 45 from 20 values. That means altogether, 20 into 500 is what's been deducted. So, is there a way to now find out summation X minus 45? Yes, there is. Summation X minus 45 is equals to 1218 given earlier minus 900, which is equal to 318. So what do we have? We have summation X minus 45, which is equal to 318. Now, any questions so far? Don't worry about how we're going to find summation X minus 45, the whole thing square. And if you're thinking that we're just going to square the whole thing, that's not how we're going to do it. But let me know if you have any questions so far.
Sir, I didn't get summation X minus.
Okay, I'll repeat. Let's go back to this example. Here, why did we multiply by 20? Okay, don't worry about it. Let's go back to this example. Now, pay close attention. What is the sum of all the values of X over here for this data set? Sum of all the values of X, let's do it in fact. It's 22. Okay. Now here, you're adding 2 to all values of X. Correct? How many values of x do we have?
5.
We have 5. So if I'm adding 2 to all these 5 values, can I say that altogether I'm adding 10? Can I say that? If I'm adding 2 to 5 values, can I say that altogether, in order to find out of summation x plus 2, I'm taking the sum of the original values of x and in it adding 10? Can I say that?
Yes, sir.
Where did the 10 come from?
It's like the total number of additions you've made.
Exactly. Because we're adding 2 and because we have 5 values. So where did the 10 come from? 2 into 5. If we're adding 2 in 5 values, that means we're adding the total amount of values that we're adding. The total amount that we're adding can be found by simply doing 2 into 5, which is 10. Okay, just like that over here. If I'm subtracting 1 from all the 5 values, so technically, what am I doing to summation x? What am I doing to the original sum? What am I subtracting from the original sum? I'm subtracting 5. That's correct. Okay. Does that make sense, Barira? Let's go back to this example now. Here I'm subtracting 45 from all the values of x. How many values do we have? We have 20 values. If I'm subtracting 45 from 20 values, that means the total amount that I'm actually deducting is 20 times 45, which is 900. So this is what we have. Okay, now it's time to find this. Now, I will solve this, but I want your input. What do you think I should do in order to find this? Sir, we can calculate mean. Yes, yes. But what should I make use of? That's what my question is. What should I make use of in order to calculate summation x minus 45? The variance being equal. That is correct. Now remember, we saw earlier that the new variance is going to be the same as the old variance. And we already have what the old variance is. What is that? That's 17.64. Now, how will I calculate the new variance? In order to calculate the new variance, I will take the sum of all the values after 45 has been deducted. Sum of the square of all the values after 45 has been deducted, divided by the total frequency, which is 20, sorry, and then I will calculate the new mean. How will I calculate the new mean? For that, I need the sum of all the values after 45 has been deducted, divided by 20. Okay, and this is what we're going to square. So let's simplify this. Summation x minus 45, the whole thing square upon 20. What's the sum? What's summation x minus 45? That's 318 divided by 20, the whole thing square equals to 17.64. Now let's solve this, see what we get. In the meantime, if you have any questions, feel free to ask. $318 divided by 20, the whole thing square, into 20. So what do we get? We get 5,409. Summation x minus 45, the whole thing square, equals to 5,409. Okay, whatever confusion you have, let's clear it out. So I'll explain this again. Summation x minus 45, the whole thing square. Now, when you look at summation x minus 45, the whole thing square, where do we use this? Where do we use the square of all the values? We use it in variance, number one, okay? So that means I can use the variance in order to calculate this. I know that the new variance with the new values will be equal to the old variance with the old values. And I already have the variance, okay? The question did not give it to me. The question gave the standard deviation, but I can always square it and get the variance, okay? Now, if I want to calculate the new variance, how will I do that? I will take the sum of the square of all the values after something has been added or deducted. So that means I will take summation x minus 45, the whole thing squared, divided by the total frequency, and from this I will subtract the square of the new mean. New mean means that I need to take the sum of all the values after 45 has been deducted. Do we have that? Yes, we have that. That's 318. Divided by the total frequency, which is 20, again given in the question, and then don't forget to square it, because that's what the formula is. And then we equate it to 1764. You substitute summation x minus 45 with 318. Solve this, solve for summation x minus 45 whole squared, and this is what you end up with. Now I will do one more example. Okay, I'll do one more example, so don't worry about it. let me know if you have any questions so far. Once you solve like 4 or 5 questions, you will notice that the questions are very similar to one another. Okay. So here's another question. Let's see how we're going to do this. The amounts of money, X dollars, that 24 people had in their pockets are summarized by so and so. So we're talking about 24 people. Okay. X is what we're measuring, and that's dollars. Are summarized by summation x minus 36 equals to minus 60. Summation x minus 36 equals to minus 60. And we're given summation x minus 36 whole squared to be 227.76. Okay. Now, one thing that I've missed is the total frequency, or n, which is 24. Okay, n or total frequency, doesn't matter how you write it. Either way, it's 24 since we're talking about 24 people. Okay. What do we have to find? We have to find summation x. Now, what do we have? We have the sum after 36 has been deducted. And how many values do you think 36 must have been deducted from? How many values 36? No, how many values has 36 been deducted from? 24. That's correct. Okay. So let's make a formula for this. Summation x minus 36 is equal to summation x minus 24 into 36. In the end, I'll make you guys write down all the formulas as well. Okay, there's a formula for this also. We'll write it down in the end, inshallah. So we have summation x minus 36, which is minus 60. We don't have summation x, but that's what we're here to find. Minus 24 into 36, which is equal to what? 24 into 36, that's equal to 864. 864. So through this, we can find summation x, which is equal to 804. Yes, Mahad, your answer is correct. Any questions so far? Okay, great. Acha. Now we have to find summation x square. What do we have to find? We have to find summation x square. What are we going to do over here? This is the formula that we're going to use, that the new variance equals to the old variance. Now notice we don't even have the old variance. Okay, that means we're going to calculate the old variance now. Okay. Now how will I calculate the new variance? Let's start with that. For the new variance, I will use the sum of the square of all the values after 36 has been deducted divided by the total number of values, which is 24, minus the new mean. How will I calculate the new mean? Question for you guys. How will I calculate the new mean? Minus 60 upon 24. That's correct. So for the new mean, I will take the sum of the new values. That means I will take summation x minus 36. So let me not write down the value straight away. Let me write summation x minus 36 divided by the total values, which is 24. And this is what I'm going to square. Okay. And then this is going to be equal to the old variance. Now, how will I calculate the old variance? The old variance, I use the formula summation x squared upon n, which is 24, minus summation x upon n, the whole thing squared. Okay, now notice that we have everything except for summation x squared, and that's what we have to find. Do we have summation x minus 36, the whole thing squared? Yes, it's given in the question. 227.76 divided by 24 minus, do we have summation x minus 36? Yes, we do. It's minus 60 over 24, the whole thing squared. Do we have summation x squared? No, we don't. That's what we're here to find out. Divide by 24. Do we have summation x? Yes, we worked that out earlier. 804 divided by the number of values, which is 24. And then don't forget to square it. All right. Now let's work this out. See what we get. Again, a lot of calculations that we have to do over here. So let's start with 227.76 divided by 24 minus, in a bracket, minus 60 upon 24. Nope, I'm afraid that's not the correct answer. Minus 60 upon 24, the whole thing square. Plus, if you take this across, so plus, in a bracket, 804 upon 24, the whole thing squared. And then in the end, don't forget to multiply by 24, which gives you summation x squared to be 27,011.76. Okay, and since this is the exact answer, we leave it over here only. 27,011.76. and 11.76. Now, take a good look at it. Let me know if you have any questions. I know it's getting tough, but that's how it is. I can't keep you guys under the illusion that it's all very easy and fun and games. But yeah, let me know what your thoughts are. Yeah. So for this chapter, for this particular concept, you will notice that majority of the questions are very similar. Majority. So like you can say that if let's say you have normal distribution, so you'll notice that nearly all the questions are normal distribution, with the exception of a few, they look the same. Okay. Just like that, if you have, let's say, binomial, most of the binomial questions also, I mean, you have like 3-4 concepts. Okay, so things revolve around 3-4 concepts only. So with after a certain amount of practice, you will notice that it's just the same thing over and over again.
Right, sir.
But for that, you need to practice quite a lot. Okay, you won't have that feeling just after, let's say, 2 or 3 years of past papers. You need to practice at least 5-6 years of past papers. That is correct. 16.81. Now find summation x squared. If you've done everything correctly so far, you should get the correct summation x squared as well. That is also correct. 63,811. Okay. So this is a very recent question. I hope everyone has been able to solve the previous question correctly. If not, in fact, I'll just write down the working anyway. So how will you find out the variance? So for the variance, you can either use the new values or the old values. You know the answer will remain the same. Okay, that's what we saw earlier. So if you want to find out the variance, here's what you're going to do. You're going to take summation x minus 50, the whole thing square, divide by the number of cars, that's 22. And from it, you will subtract the square of the new mean. Okay, and for the new mean, you need the sum of the new values, which you already have. So summation x minus 50, the whole thing squared, is also something that you have, divided by 22, minus summation x minus 50 is also something that you already have, 81.4, divided by 22, and then don't forget to square it. This will give you the variance. And then you can use this to find out the to find out summation x squared. Okay, so how will you do that? Let me quickly do that also. So whatever the variance is equal to summation x square divided by 22 minus, now if the new mean x bar is 81.4 divided by 22, if the new mean is 3.7, okay, and when I say new mean, I mean the mean of all the values after 50 has been subtracted. So what will be the actual mean? What will be summation x upon 22? Question for you guys. If the new mean 53.7, that's correct. How is that? That's because if you subtract 50 from all the values and after that the mean that you're getting is 3.7, that means the mean before you subtracted 50 from all the values must have been 53.7. Why? Because when something is subtracted from all values of x, the same is subtracted from mean as well. So the old mean must have been 53.7. Okay, so when you solve this, you get summation x squared as well. Okay. All right, so this is one question that I would like to solve. In fact, I'll give you guys a few minutes. I'll give you guys 3 minutes to try this question on your own. Okay, at least the first part, and see if you guys are able to do it. You will be able to do it. I mean, there's no there's. It's not that this question is entirely new or this concept is entirely new. Case 21. All right, let's find out. So let's see how we're going to find out k. Okay, let's see how we're going to find out k. So the question says, given that the mean of these 40 values is 34. Okay, so the mean of these 40 values of x is 34. How does that help? Here's how that helps. Summation x upon n is equal to 34. So summation x upon 40 is equal to what? Is equal to 34. Okay, now let's cross multiply. What's 40 times 34? That's 1360. That means summation x is 1360. Okay, now here's the thing. Summation x minus k equals to 520. Now let's decipher summation x minus k. This means that we take the sum of all the values of x. From all these values, we subtract k. And how many values are these? These are 40 values. So from all these values, we subtract k, which means we end up subtracting 40 times k, which is equal to what? Which is equal to 520. Sorry, it's not 50, it's 520. Okay, so we have summation x, that's 1360. Okay, minus 40k equals to 520, and if you solve this, 1360 minus 520 divided by 40, so we get the value of k as 21. Okay, now there's another way of doing this as well. I'll do that also. The other way is to use the mean. Okay, ultimately, if you look at the calculation in the background, you'll notice it's the exact same thing. So the new mean can be found by doing summation x upon n, and from that, if you subtract k, what do you end up with? You end up with the new mean. Okay, that means you end up with summation x minus k upon n. This is what you end up with. Okay, now we already have summation x, which is 1360, upon n, which is 40, minus k gives you 520 upon 520 upon the total values, which is 40. So here also, it's not exactly any different from what we have done earlier. So you get k is equals to 21. Okay, so here you have two methods, and now you can solve the next part. It's fairly easy. If you've done the first part correctly, you can solve the next part as well. Okay, so I'm going to stop here. Remember, this concept is easy after you practice it a lot. Okay, only after doing lots and lots of questions will this concept become easy for you. And even after you've reached that point where you can say, okay, I finally got in the hang of this concept, make sure that you constantly keep on practicing this. Okay, so that you don't forget. It's very easy to forget this concept. All right, because there's so many formulas, so many calculations going on, it's very easy to forget. All right, so I'll give you guys some questions to solve. Yes, I will post the notes inshallah today only, and I will post the recording as well. But that's it for today. I'll stop here. See you guys inshallah in the next class. Next class we're going to start probability. Do not miss the next class. It's very important. We're going to start probability. And yeah, that's it for today. See you guys in the next one. Until then, take care. Allah Hafiz. Quartiles we will do when we learn how to sketch box and whisker. Okay, Badullah? Quartiles we will do when we learn how, because that's when you need quartiles. Okay, and we will do quartiles with cumulative frequency as well. All right, so that's it. Take care, everyone. Allah Hafiz.